that simple. S-I-M-P-L-E, simple as can be. It's just that simple. S-I-M-P-L-E, simple as can be. It's just that simple. S-I-M-P-L-E, simple as can be.
Hi, in this video we're going to talk about the difference between a simple random sample and a random sample. Now when we examine the definitions, it's not quite obvious what the difference is. A simple random sample is when subjects are selected in such a way that every possible sample of the same size, N, has the same chance of being chosen. In other words, all combinations are possible. A random sample is simply if all members of the population have the same chance of being selected. Okay? And maybe all combinations are not possible. So let's look at an example. If I had 16 students in a classroom and I wanted to pick 4 students at random, I could put all the names in the hat, close my eyes, and pick them. So I might pick Josh and Frank, and then Sierra and Nancy. Okay, so they were picked at random. All right, so I have Nancy, Frank. I'll just write those out so you can see. Nancy, Frank, Josh, Sierra. All right. Now the next time I do this, let's put them all back. I might come in and do another random selection of 4. All right, let's say I get Mark, Jack, Frank, George. Okay. All right, so this might be one selection if I pick these 4. This might be another selection if I pick these 4. Notice in this example, if I pretend that I have all the names in the hat, I'm picking 4 out of 16. Okay, so every student has a 1 in 4 chance of being picked. Okay, but notice here, in this first selection, Frank was with Nancy, Josh, and Sierra, and in the second selection, Frank was with Mark, Jack, and George. Not the same combinations, okay? And that's what I mean by combination. All combinations are possible. So this would be a simple random sample, because all combinations are possible, right? So when we think about a simple random sample, think about names in a hat. And I'm just going to draw them out. Every combination is possible, and everybody has the same chance of being selected. Now a random sample has that same idea, that everybody has the same chance of being selected, but not all combinations are possible. So instead of putting names in a hat, I'm going to say give each row a number. Okay, I should say column. Then I'm going to pick a number between 1 and 4. Let's just say that I picked 2. Okay, and now everybody in column 2 is going to be the winner. So I'd have Bob, Frank, he's a lucky guy, Kim, Caleb. All right, so they're all the winners. Now notice, it'd be impossible for Frank to win with anybody else. All right, because if Frank wins, he has to win with Bob, Kim, and Caleb. All right, so you can see that if I do it this way, not all combinations are possible. Okay, in other words, Frank can only win with these people. If this row wins, Laura, Sierra, Josh, and Jenna can only win together. Okay, but does that change the likelihood of them winning? Well, look here, there's 4 columns, so I'm going to pick 1. Everybody still has a 1 in 4 chance of winning. So notice that everybody still has the same probability of winning, whether I do a simple random sample or a random sample, but the difference is whether or not you can be paired with any combination. So if we go back to our definition and review it, it should make a little more sense. Remember that we said a simple random sample, all combinations are possible. Put names in a hat, anybody can get picked and paired with anybody else. But in a random sample, it doesn't have that strict requirement. It only requires that all members of the population have the same chance of being selected. So if it's a 1 in 4 chance, it's a 1 in 4 chance, and all combinations may not be possible. I hope this clarifies the difference between a simple random sample and a random sample.
Just that simple, S-I-M-P-L-E, simple as